Alright, so we are going to take a look at solving quadratics by completing the square. So far, we've solved quadratics by factoring and applying the zero product property, which has been great, but the problem is that we can't always factor the quadratic. And so, we're going to take a look at some quadratics that are not factorable today and work through another option for solving them. Hopefully you have been able to print off the document that goes along with this screencast. There are 4 problems that we're going to work through, and the first problem in the first box is x squared plus 2x equals 7. So if this were a typical quadratic, we would think that we would want to move c, which would be 7, over to the other side. It would become -7, and we would try to factor it. But hopefully you can take a look at that and see that we actually can't factor it. So we're going to complete the square, and we're going to solve that way. So here's the first thing we're going to do. We're going to rewrite this equation, and since we're going to complete the square, it means we're creating a new c. And so we're going to leave a place for it right here. Now this is a nice equation to complete the square with, because we take b divided by 2 and square it. So 2 divided by 2 is 1, and 1 squared is 1. Now when we were completing the square with quadratic expressions and functions to be able to put them into vertex form for the purposes of graphing, we said that we can't just walk around and add 1 wherever we want, for example. So because we've added 1 to this side, we need to go ahead and add 1 to the other side. We're balancing out the equation. The value of adding 1 to this side is that now we have a nice perfect square trinomial that we can factor very simply, and so all we've had to do is add 1 to the other side, and we still have the exact same equation as what we started with. Alright, so we have solved problems before that are a little bit simpler than this. Let's say I gave you x squared equals 4, and I asked you to solve that. So you would take the square root of both sides and get x equals plus or minus 2. Well, this is basically the same thing. It's just that instead of this being x squared, it's x plus 1 squared. It's still the same thing. So to solve this, we're going to take the square root of both sides. And the square root of something squared is itself. And this is going to be the square root of 8. So plus or minus the square root of 8. This makes it much easier to isolate x. And so x is equal to -1 plus or minus the square root of 8. And now we're in a situation where we could simplify that 8 under the radical if we wanted to, and if we wanted to, it would be 2 root 2. Okay, so the solution, there are actually 2 solutions to this quadratic. It's x is equal to -1 plus 2 root 2, and x is equal to -1 minus 2 root 2. Excellent. Let's do the next one. Next one's a little bit harder. We're going to add a step here. And so we're going to take c that is sitting in the spot that we would expect it to be in, and we're going to move it out of the way. Bring it over to the other side and leave a space for us to create a new c. This one is tougher as well because b is not nicely divisible by 2, and we're going to end up with a fraction, but that is okay. So here we go. We're going to first rewrite this, leaving the space for our new c and moving the 2 to the other side. Negative on this side, it becomes positive on this side. Alright, so to get c, we're going to divide b by 2 and square it. That means this is going to be 49/4. 7 divided by 2 squared is 49/4. And if we're going to add 49/4 to one side, we have to add it to the other side. Now, even though this looks messy to factor, we know that it's not, because we know that this number is what we did to b just before we squared it to get this. So it's 7/2. And I'm going to not call this 2. I'm going to call this 8/4. so that we have a common denominator. 8 over 4 is 2, but now I can add these. So I've got x minus 7 halves squared is equal to 57 fourths. Beautiful. And now, just like last time, we have this perfect square. We can take the square root of it, and that means that we'll have to do the same thing on the other side. So taking the square root, we get x minus 7 halves is equal to plus or minus the square root of 57 over 4. Excellent. Okay, here's the thing though. I hope that you're seeing that we could take the square root of 4, right? So when we move this over, I'm going to do two things. I'm going to isolate x, but I'm also going to separate this radical. So we could look at this as the square root of 57 over the square root of 4. And so we get positive 7 halves plus or minus the square root of 57 over 2, right? Square root of 4 is 2. And we could take it one step further, and we could call this 7 plus or minus the square root of 57 all over 2, because these denominators are common already. All right, sound good? Let's move on to a slightly tougher problem. So when we were doing vertex form, we said that we can't complete the square until we make sure that a is 1. And right now we have a 2 sitting in front. Now, if you look at the rest of the equation, that's actually not an issue, because this is divisible by 2, this is divisible by 2, and so is this. And since this is an equation, and we really don't want that 2 there anyways, I'm just going to go through and I'm going to divide everything by 2. Because I can, and because it's going to reduce my numbers, which is always a good thing when you're trying to solve. So that leaves us with x squared minus 3x. I'm going to leave that space for our new c, and it's equal to 21, isn't it? Okay. Good. So now we're going to complete the square on this side, which means we're going to divide b by 2 and square it, so we get 9 over 4, and we're going to add 9 fourths to this side. And now I'm going to factor this, so x minus 3 halves squared. And I'm going to call this not 21, but 84 over 4, and then I've got my plus 9 fourths. So now I have x minus 3 halves squared is equal to 93 fourths. And I'm in a position now where I can take the square root of both sides. So I'm going to take the square root of both sides and get x minus 3 halves on this side. And this is plus or minus the square root of 93 over 4. Again, I hope you're recognizing that this 4 is a perfect square, so we can square root it. So I'm going to move, I'm now going to isolate x, moving this 3 halves over to the other side. So now we have x is equal to 3 halves plus or minus the square root of 93 over 2. Did all of that in one fell swoop. Very nice. And so now I have x is equal to 3 plus or minus the square root of 93 all over 2, because we were given that beautiful common denominator. All right. This is the last one on the handout, and I would say this one's a little bit tougher, but still not too bad. Okay, so in the previous problem, the first thing we did was we divided everything by 2. I mean, that was nice to do because everything was easily divisible by 2. In this one, I'm not going to do that because I'm looking ahead, and if I divide this by 3, that's cool. If I divide this by 3, still okay. If I divide this by 3, it's 1/3. Not that we care if we're dealing with 1/3, but I wonder if I were to just pull the 3 out in front, if it would become easier to work with when I decide that I'm finally going to divide by 3. I don't know the answer to that, so let's just do it by pulling the 3 out in front and see what happens. Alright, so I'm going to pull 3 out here, and I'm going to get x squared plus 2x, and I'm going to go ahead and leave that space for my new c, and I'm going to leave that as 1. So now I'm going to complete this square by adding 1. 2 divided by 2 is 1, 1 squared is 1. I would like you to remember that we did not just add 1 to this side, did we? What did we add? Okay, this is not x squared, it's 3x squared. This is not 6x, this is not 2x, it's 6x. And this is not 1, it's 3. And since we added 3 to this side, we have to add 3 to that side. Very good. So now we have 3 times x plus 1 squared is equal to 4. And now I'm going to go ahead and divide both sides by 3. Would have been great if this had come out to be 6 or something like that. We didn't know that in the beginning, but it was worth a shot. So now we have x plus 1 squared is equal to 4/3. At this point, we're trying to isolate x, and so the first thing we have to do is get rid of this coefficient out in front. That's our first step. So we take this coefficient and get it over onto the other side. Now, our next step is going to be taking the square root of both sides. So we get x plus 1 is equal to plus or minus the square root of 4/3. I know, I'm quite sure you're seeing that 4 right there. We're going to deal with that in just a second. Let's move this 1 over to the other side, and we have 4/3 under the radical sign. Alright, now look, here's the problem. If I take the square root of 4, that's fine. I'm still going to end up with a radical downstairs on the bottom, right? So this is plus or minus 2 over root 3. And we need to rationalize that denominator. We can't leave that radical on the bottom. So I'm going to move this over just a little bit, and right here we're going to remind ourselves how to rationalize a denominator. So I have 2 over root 3. To rationalize the denominator, I'm going to multiply by root 3 over root 3, which is just 1. We're allowed to multiply anything we'd like by 1. So when I multiply the top, I get 2 root 3, and when I multiply the bottom, the square root of 3 times the square root of 3 is 3. Awesome. So now we have x is equal to negative 1 plus or minus 2 root 3 over 3. Okay. If we wanted to take that one more step, and we don't have to, but if we wanted to, we could get all of this to be just one term. By instead of calling this negative 1, we could call it 3 over 3. So x is equal to negative 3 over 3 plus or minus 2 root 3 over 3. And now we have a common denominator, and so we could call it x is equal to negative 3 plus or minus 2 root 3 all over 3. And there is our final answer. Again, I know this is a quadratic. We can see that here we need to have 2 solutions to this typically, and so here are the 2 solutions. It's negative 3 plus 2 root 3 over 3 and negative 3 minus 2 root 3 over 3. So indeed we have our 2 solutions. Alright, so if you need any further help with solving by completing the square, email me, come see me in the morning or after school, and we will work through it together. I hope this helps you to complete your homework assignment tonight, and I will see you tomorrow.